guys, so this is kind of an introduction to word problems with percents, so applications that have to do with that. So these are kind of like more the basic ones. I have a second video I'm going to make about mixtures and mixing percents. So if you don't find what you want here, I have another video. You can try checking that one out. So I'm just going to jump right into this and kind of talk about like the structure of these types of problems. So in the incoming freshman class of English majors, 52% of them were female. If there were 2,300 females majoring in English that year, what was the total number of English majors? Okay, so if you've ever watched my word problem videos, the big thing I talk about is you want to identify where does the equal sign fall in this situation. I think if you can figure that out, then you kind of make the problem, you turn it into pieces and it makes it not so overwhelming. So as I read over this, I've got this 52% of all English majors are female, and that comes out to 2,300 females. And the thing I'm trying to figure out was what was the total number of English majors. So the first thing that you want to do with problems like this is try to describe all of this information using just one sentence and an equal sign. So I have 52% of English majors, I'll write this down here. This is going to be is female. So that came out to 2,300. Okay, so there's kind of like me summarizing what happened here. So where the equal sign comes in is this will equal 2,300. So that's the big thing. Once you figured that out, the rest of this now we can kind of put together. So all of this just needs to equal 2,300. So I can go ahead and set that up. So equals 2,300. And then I've got 52% of English majors. Okay, I'm trying to figure out what is the total number of English majors. So since I don't know that, and this right here is referring to all English majors, this is going to be my X. Now, what does the word of mean? Of is referring to multiplication. I've talked about that in other videos. So a lot of times when you see of, it means multiply. So now I just have to translate 52% into a decimal like this. So I've got 0.052 times X, and then that equals 2,300. And so now I can just finish solving this. I'm good to go. So I can just divide both sides by 0.52, and then I get the X equals 4,423.08. Okay, now obviously there's a problem with this. So I did actually set this up intentionally. What happens if you get like a decimal answer? So what this would indicate to you is that this 52% is actually probably also rounded in these figures. So then you can't have 0.08 of a student. So then you would just round this to 4424, right? To kind of make up for that 0.08 of the student. So that is the idea behind that one. Okay, so now let's look at this next one. So when Hector bought his house, it was worth $232,000. After a few years, the house's value is increased by 22%. What is the increase in the value of the house, and what is the actual current value? Okay, so once again, it's all about figuring out where is the equal sign. And I want to like just point out what this is talking about. So we might actually want to refer to this list. So these are words that imply certain operations. So the thing I want to point out here is that this problem talks about increased by. This is actually really important because increased by indicates that you want to use addition. So that's going to help you frame kind of how this starts. So I have the original worth of the house, which was $232,000. And then there was the increase. It was increased by 22%. So this is what this is talking about. Starting here, we need to increase the value by 22%. And then this is going to equal what? The current value. So this is actually a very different setup than the last one. The last one had the words of and was indicating things like multiplication. This one is using increase by, so it's indicating addition, and it's a very different setup. Now, let's think about what does this mean. So I'm this right here, increase of 22%. 22% of what? It's 22% of the original value, right? So this right here is actually telling you the operation to do. And then what are we trying to find here? We're trying to figure out what is this current value. So the current value in this case is kind of our x, right? So I've got 232,000. Now, how do I indicate this 22% of the original value? Well, I'm going to take 0.22 of, or multiplied by, 232,000. And that's going to give me my current value. I can call it current value or I can call it x, either way. So in this case, there's actually no real solving that you have to do, right? Other than just doing this operation. It's not like you have to go through this whole thing to solve for x. We're just going to get that as a consequence. So as I work this out, this will come out to 51,040. And then I can just add those together to get $283,040. So you have to really think about the language, and again, thinking about where that equal sign falls. Now there's two questions here. The first, one of them is what is the increase in value, and then what is the actual current value. So this right here, this would be the current value. We know that as a consequence of how we set this up, but also we figured out what the increase was in our work, right? So this part that I added on, this is the increase. So the increase in this case would be 51,040, and there you go. So you really want to think about the language, and if you don't have this list next to you, maybe you want to pause the video and write it down, because sometimes this can kind of help set you straight as to what operation you want to use. All right, so Devin wanted to buy a shirt that normally costs $18, and when he goes to the register to buy it, he found out there was a 55% discount. So what is the price of the shirt now? Okay, so once again, we kind of have to think about what is actually happening here. So I've got this shirt, and so what is this discount going to actually do to the shirt? So you actually want to think through what happens with this, because it's not always just spelled out in the problem. The way that a discount works is it decreases the price by a certain amount. And if I think about the idea of decrease, that has to do with subtraction. So this is why kind of having this list in front of you can be really helpful as you set up the structure. So I'm going to have the cost of the shirt. So the cost of the shirt, and then I'm going to have the minus the discount. So it's the discount on the shirt, and that's going to give me the sale price. So notice that in this, I'm not necessarily always using x's. I'm just kind of coming up with a structure. But again, once I figure out where that equal sign goes, now I can kind of figure the rest of this stuff out. So I know the cost of the shirt. The cost of the shirt was $18. Now, the discount is 55% of the normal price. So that idea of means I'm going to take 55% times the normal price, like this. And this is what's going to give me the sale price. That's what I'm looking for. So you can either call this sale price, maybe I'll just call it S instead of X. So here's what I have to actually work out then. So if I do the math here, I'm going to subtract off $9.90, and that will give me the sale price. So this comes out to $8.10. So that's my sale price. So once again, so we didn't have like an X that we necessarily had to solve for, an S that we had to solve for. Just in figuring out the structure of the problem, everything else kind of just came together. Okay, so Rachel buys dresses for a clothing store at $8 wholesale. And when she gets to the store, she marks them up 23%. So how much does she sell each dress for? Okay, so once again, it's all about figuring out the equal sign. I highly recommend you pause the video here and you try to do this on your own and then hit play. So she's got the wholesale price. So this is the wholesale price. She goes and buys some dresses, but then she does the increase on the price of 23%. So once again, this idea of the increase is going to mean that we're going to add on that percentage. And so then this is going to be the store price, I guess. We'll call it the store price. So this is what we as consumers would pay. So here's my structure. My wholesale price in this case was $8, and then I need to have an increase of 23%. So it's 23% of that wholesale price. So there's what I'm going to have. And so then this is going to be my new store price. So I can just say that equals S again. Okay, so now I can go ahead and work this out. So this comes out to 184. And so if I add those together, I get 984 is my store price. So that's what she would put down on the tag. Okay, Mia is buying a new laptop for $800. There is a 6.25% sales tax in her county. So what is the final price of her laptop? So once again, why don't you try to set this up and figure out where the equal sign goes in the basic structure of the problem, and then hit play when you're ready. So I have the price of the laptop, and then as I think about what happens with this, the price of the laptop, so a tax is an increase on the price. So once again, it's this idea of this increase. So once I think of increase, it means I'm going to have to add. So I need to add on the tax of 6.25%, and then this is going to give me my final price. So once again, now I figure out what information do I know. I know the price of the laptop was $800, and then I need to take 6.25%, so that's 0.625 times the 800, and that will get me the final price. So that's going to come out to 50. So then I get $850 is the final price in this situation. Okay, so this one is going to be a little bit different now. So let's read this. So Rose found a shirt she wanted for $24, and when the cashier rang up the shirt, she owed $25.98. So I want to figure out what is the actual percentage of tax that she paid in this situation. Now, once again, and we've kind of talked about this situation over and over, but now there's a little bit of a plot twist, I guess, because we're trying to figure out what the percent actually was. I want you to try to set this up once again using that same method of where's the equal sign go, and then maybe even try to set up the equation. This will be a very different setup, so you might have to think about it for a moment and just make a guess. The worst thing that happens is that you're not right, but you'll learn something from it, so that's totally fine. And then hit play when you're ready. Okay, so I have the shirt price plus the tax on the shirt. I don't know what that is. And that comes out to the final price. Okay, so let's fill in what information I know. So my shirt price was $24. I'm just going to leave this alone for a moment. And I know what the final price is, right? The final price was $25.98. So let's think about for a second, how have we been calculating tax? So tax would be the percentage, which I don't know, but it would be the percentage times the price. So that thing that I don't know, I'll just use as X, but I can multiply that times the price. So here's kind of what we're setting up. Okay, so now I can just go ahead and solve this as usual. So I can actually solve for X in this case, so I have some work to do. So this will come out to 24X equals 198, and then if I divide both sides by 24, I get 0.0825. So the tax rate would be 8.25% in this town. So very similar setup to before. It's just in the context of this particular problem. To calculate the tax, since we didn't know what the rate was, we just wrote it as X. So that's what I have for these problems. And then, like I said, I have other problems where I talk about more percentages and mixing them up. So if you're looking for other types of problems, I recommend you check out the other video. But if you guys have questions, feel free to just leave me a comment. If there was something else that you weren't sure of or that you wanted to see, you can always just leave me a comment. And, if I have time, then I can make more videos. Thanks for watching, guys.